Hello students, this lecture is about integration by partial fraction. First of all, we need to learn what is partial fraction.
Partial fraction is decomposition of fraction. So if we have a big fraction and we decompose, so decomposition of a big fraction into simpler fraction so that we can easily apply the integration. Main task is only to apply the integration, right? If we have the bigger fraction and we want to make it simple, so we'll decompose it. For example, if you have this fraction, n of s is the numerator polynomial. It can be any polynomial. We are not concerned about that because we don't need to simplify that one. We only concerned about the numerator. So we have to make the factors of denominator function and break it into some parts. How would we break it? I will explain you. First of all, you should know how to make the factors of this denominator function. Okay, so by using these steps, we can simplify this denominator term. So here you can see you have a big this term and you have to make the factors. So what we do, from the first two terms, take x4 as a common and the inside it left as x plus 1, and from the second two terms we take the common negative sign and x plus 1. From both terms you can check that x plus 1 and x plus 1 is a common term and left is x4 minus 1. This is how we do the factorization. And then x4 minus 1 is again break into x square plus 1 and x square minus 1 and x plus 1 as it is. And then x square minus 1 is again break into x plus 1 and x minus 1, and this x plus 1 and the first x square plus 1 is as it is, because if you have the square term this cannot be simplified with the plus sign, but x square minus 1 can be again break into x plus 1 and x minus 1. And look at this, if you notice that x plus 1 and x plus 1 both are the same term, so we can combine it. We can write it as x plus 1 whole square, and one term is x square plus 1 and one term is left is x minus 1. So basically in this last term we have rearranged the terms. First is a linear term, second term is again a linear but with the whole power 2, and third term with the square term. Basically we have decomposed it into three parts. One part is x minus 1, which is only the linear term, x plus 1 square, which is also the linear term. Okay, doesn't matter if the whole power is 2 or 3 or 5, but still a linear function, because you know that the linear function is a function which have the x power 1. So here the x power is 1, and the other term is the x has 2 power. It means this is a quadratic term. After making the factors, actually we want to decompose this whole fraction. This gives us the idea to break the term. How? Numerator term as it is, we will not change the numerator term, but the denominator now make these factors instead of this polynomial. So it becomes x minus 1, x plus 1 square, and x square plus 1, because we found these factors from this polynomial. That's why instead of this polynomial now we'll replace the factors. But why we do this? We make these factors so that we can make this small fraction instead of this big fraction, because if you try to take the integration of this with the denominator of long polynomial, that is very difficult to find.
So using these factors, we will make the partial fractions. Each partial fraction will have the factors on the denominator and the numerator will be some constant.
One factor with x minus 1 plus other fraction will be with x plus 1. But you know that x plus 1 is also a linear term with the power. Power 2 means 1 with the power 1, other is with the power 2. First fraction with x minus 1 denominator, second fraction is with x plus 1 only with 1 power. Then because it's a 2 power, so we have to complete the 2 power. So x plus 1 with the 2 power, so it's not 3 power here, x plus 1 with the 2 power, plus now the other term with x square plus 1. Like more you have, the more power will make the more fractions. But how to write the numerators? So when the denominator is x minus 1, we write only one constant, that is a. The other is again linear factor, again you write another constant b only. Then you have another linear factor with the 2 power, but it's still a linear factor, so you write another constant c. Remember that every time whenever you have a linear factor on the denominator, numerator will be only a single constant. But when you have the denominator term with the square power, like a quadratic function, there's a difference between these two. This is also a linear factor with the whole power 2, but this is a quadratic factor. So when the factor is quadratic, then you write two constant. But how? After C we use D and E, right? So but we write dx plus E. This is how we use the term when you have the quadratic factor. So basically this one rational fraction is decomposed into smaller 4 fractions. Got it? So this is actually the way to write the term into this one. Once we have break into 4 fractions or 3 fractions or 5 fractions, whatever, after that we have to find the value of A, B, C, D, E. And once we find all of them, we'll plug it there.
Then it will be completely decomposed. The main thing is you have to remember these rules of making partial
So
fractions.
first thing, when you have improper fraction, what is improper fraction? If you have the degree of the numerator is greater than or equal to the degree of denominator term. For example, you have 2x square plus 1 divided by 2x minus 3. So see, what is the highest power of numerator term? It is 2, variable highest power. But the denominator highest power is 1. So this is improper fraction. If you have improper fractions, so we don't directly decompose into some smaller fractions. First, we have to divide this. Once we divide, then we'll get a remainder plus a fraction. So now this fraction will be a proper fraction. And after that, we have to do the same thing that I explained you above. Now the second thing is, if the denominator factors look like this, means px plus q with the power m. What is px plus q? Like if you have the linear factor. So when it is a linear factor, we break it like this: a1, a2, a3 or abc, like whatever, like a single constant on the numerator. And how the denominator, like if for example if it is m power, so first with 1 power, then with 2 power, then 3 power, until the power is complete. So it depends on the power, that how many parts of this will be. Next is, if you have the quadratic factor like this, in which the highest power is 2. So I told you that when the highest power is 2, it's a quadratic factor like this. Like we use 2 constant in the one term. So 2 constant will be like this. First constant with x and second constant alone. Okay. So like we have the denominator with the quadratic factor, and above is bx plus c. They use b1 and c1. I use just b and c. They are just symbols to represent the constants. So the only point that you need to remember, if you have the linear factor, then write only with one constant above, and if you have the quadratic factor, then write with the 2 constant, one constant with x and second constant alone. So if we will solve some question, you will understand it clearly. In the example 1, we have to divide into the partial fractions, the decomposition method. But for this, first of all, we make the factors. The factors would be x minus 2 and x minus 3. Look at these factors. The both factors are the linear factors. So the partial fraction will become a over x minus 2 plus b over x minus 3. This is how we divide it. But what we do after this, that's the main thing, because you have not learned yet that how to solve it further, how to find a and b value. So keep in mind, now your question is this one instead of this, because you have break it into this part. So what we do, you have this equation, and first thing is we remove the denominator. The first is on the left side, you have the denominator x minus 2 times x minus 3, and on the right side you also have the same factor x minus 2 and x minus 3. So all we have to do is we will multiply with these two factors on both sides. Okay, so that the both will be cancelled out and we will left nothing on the denominator, because we want to simplify the denominator first term. So x minus 2 and x minus 3 will multiply in this side and with this side as well, and with each term. So x minus 2, x minus 3 with a first term, and x minus 2, x minus 3 with second term as well. What will happen in this one, all terms will be cancelled out, of course, because we multiply with the same term. So what left here, only one left. But what happened here, x minus 2 cancel with x minus 2 and x minus 3 cancel with x minus 3. What terms left? Here is 1 left, and on this side a times x minus 3 left plus b. So these are the terms which are left, and now we use this equation to find these two values. Remember, whenever you have the linear factors, so after this step you have to plug the linear factors equal to 0 one by one and find the values of x and plug it here. So we have two linear factors. Put first linear factor x minus 2 equal to 0. This will give you x is equal to 2, and we'll plug x is equal to 2 in the above equation wherever the x is. So 1 equals a times 2 minus 3 plus b times 2 minus 2. So the term in which you have the same term like 2 minus 2, this will be 0. Only left is a term. So a 2 minus 3 is negative 1. So if you divide by negative 1, you will have a is equal to negative 1. This is the value of a. Now we put the second factor equal to 0 and plug the value of x in the same equation. So put x minus 3 equal to 0, you will have x equal to 3. In this equation, we'll plug x is equal to 3 same. 1 equals a times 3 minus 3 plus b times 3 minus 2. And see, 3 minus 3, this will be cancelled and this term becomes 0. 1 equal b times 1. So we have b is equal to 1. After getting the value of a and b, the only task is left the plugging the value of a and b into the equation which we have made above a and b. Let me call it as the star equation just to make it a different. So put a equal negative 1, b equal 1 in equation star. So what is the equation star? What is on the left side of this equation? On the left side of this equation is actually this term, and on the right side we have this term. So we write left side this term, the place of a and b we plug its value and denominator is same. So this would be 1 over x square minus 5x plus 6 equals a over x minus 2, right? So what is a? Minus 1. Minus 1 over x minus 2 plus b. b was 1 over x minus 3. See, this big rational fraction is divided into some small partial fractions. Now, if they ask us to find the integration of this term, so we don't need to find the integration of this because we have changed this into these two fractions. So if we find the integration of these two fractions separately, that will be the answer of this term. So let's check that how to take the integration. So what is the integration of minus 1 over x minus 2? What is the derivative of x minus 2? That's a 1, which is 1 is already there. It means if you have 1 over x, the integration is natural log of x. So same, the integration of 1 over x minus 2, like if x with some adding constant or x some subtracting constant, still natural log of x minus 2. And this negative 1 is outside. Plus integration of this will also be natural log of x minus 3 plus c. So this is actually the answer of the whole question that is given for integration. This is how partial fractions help us to find the integration of a big rational function.
There is another question which we will solve by using the partial fraction. So first we make the factors of denominator term.
So let's write the denominator term so that we can factorize it first and then we'll write in the above equation. Okay. So how to factorize? If you notice that all terms have the x term. So first is we can take x common. It left is x square plus 2x plus 1. Now x square plus 2x plus 1 can be break. It is a formula of a plus b whole square. So x plus 1 whole square. Now see, we get three factors. One factor is x, other two factors is x plus 1. Okay, so we have these three factors and now we'll break the fraction using these three factors. So let's plug the value of this denominator in the above equation. So 5x square plus 20x plus 6 divided by x times x plus 1. Instead of this term, I am writing its factor. So what will be the partial fractions? A over first factor, which is x only, plus b over x plus 1. If you have the whole power, so we start with the 1 power and keep increasing with the constant. First constant with the 1 power and another constant with the 2 power, and as it is only have 2 powers, we stop here. If it is have 3 powers, so we make another term. Here are 3 fractions of this. It's time to find a, b and c. The same step, multiply the denominator term on both sides with each term. So multiply x times x plus 1 square here, multiply x times x plus 1 square, x times x plus 1 square, and x times x plus 1 square. Multiply with each term. This x is cancelled here. X plus 1 cancel with only one factor. X plus 1 square cancel with x plus 1 square whole. And here all terms cancel out. What left is 5x square plus 20x plus 6 equals a times x plus 1 square plus b times x plus 1 plus c times x. Now this is the one equation. Let's call the above equation again the star equation, in which we'll plug the value of a, b and c. So this is the equation 1. What I told you, the next thing, I told you that if you have linear factors, you plug it equal to 0 and put the x value into the equation. So what linear factors we have? X plus 1, right? So first put x is equal to 0. So we plug just x is equal to 0 in the above equation, wherever the x is. So 5 times 0 is 0 plus 20 times 0 is 0 plus 6 equal a times 0 plus 1 plus b times 0 times 0. The whole term will be 0 plus c times 0. Because x is multiplying, so 0 times any term will be 0. Now here is 6 left and this term will become 0, this term will be vanished, only the a left. 0 plus 1 is 1 square, so that's a value is 6. We got a. Now it's time to find b and c. So one factor was x is equal to 0, we plug it. Now the other factor is x plus 1, so plus 1 equal to 0 and the x value is negative 1. So we plug the negative 1 in the same above equation. So 5 times negative 1 square plus 20 times negative 1 plus 6 equals a times negative 1 plus 1 plus b times negative 1 plus 1 plus c times negative 1. Tell me which terms will become 0. So a will be 0, b will be 0, and here 5 times negative 1 square will be 1. So 5 minus 20 will be minus 15 plus 6 equals c times negative 1, and after simplification this will give you negative 9 equals c times negative 1, and minus cancel from both sides, so c value is 9. We got c is 9, we got a is 6. Now it's time to find b. A is 6, c is 9, but still b is left here. If you notice that there are 3 constants, but we have only 2 linear factors. So how can we find the value of b? So wherever we have the more constant and less factors, so the next step is we use the comparing the coefficients. How to do the comparing coefficients? Look at this equation 1. So use this equation 1, simplify this, and after that compare the coefficients of different variables. So first of all, let's simplify this. The equation 1, it becomes 5x square plus 20x plus 6. We can say it as from equation 1. So 5x square plus 20x plus 6 equals a times, look at this. What is x plus 1 whole square? It becomes ax square. X plus 1 whole square, how can it be open? It will be open as x square plus 2x plus 1. So ax square plus 2ax plus a. Same, now multiply x with inside with b. So it becomes bx. X times x will be x square and x times 1 will be x, so plus bx, and the last is cx. Now here we see there are a lot of coefficients you have. Some coefficient with coefficient of x square only, some coefficients of x only, and some are constant. So if you have the more constant to find, we will compare the coefficients. So first is the highest variable is x square. So first we compare coefficient of x square. Coefficient means the value with x square. Now we compare the coefficient means we write the coefficient of x square from left side and from the right side both. So what is the coefficient of x square here? That is 5. And what is the coefficient of x square is a and b, right? A plus b. We just write the coefficients, not x square. Okay. So using this, by comparing the coefficient of x square, you can say comparing the coefficients, or the another way is you can write it as equating the coefficient of x square. By using this thing, we got an equation 5 is equal to a plus b. So plug the value of a, because a value we already found, which is 6, and b is that we need to find. So plug the value of a here. So it becomes 5 equals 6 plus b, and take 6 on the other side, it will be subtract. So 5 minus 6 will be -1. So we got the value of b is -1. All values has been found, a, b and c. Now plug all these values into the star equation. Star equation is on the left side, it's a question. Right side is actually a over x. A over x, so a is 6 plus 6 over x. The left side is 5x square plus 20x plus 6 divided by x cube plus 2x square plus x dx. This is the left side term, and now on the right side, this is a over, a is 6 over x plus b over x plus 1, b is -1, -1 over x plus 1, and plus c over x plus 1, 9 over x plus 1 square. So see, we have the rational fraction and we break into some smaller fractions. If you integrate all threes, you will get the answer of this one. So it becomes 6 natural log of x. Yes, so negative will be outside and it becomes ln of x plus 1 and plus so 9 over x plus 1 square. So square means we can use the power rule. So 9 will be outside and power rule will be x plus 1 with the -2 plus 1 over -2 plus 1. So by simplifying 6 ln of x minus ln of x plus 1 and -2 plus 1 will become -1. So this negative will be positive, becomes -9, and x plus 1 with the negative power will be go on the denominator. So x plus 1 plus c. This is the answer of the integration of 5x squared plus 20x plus 6 with this denominator term. Okay.